plastic is rubbed against a wool shirt, thereby acquiring a charge of minus 0.8 microcoulombs. So the charge it acquires is minus 0.8 microcoulombs. How many electrons are transferred from the wool shirt to the plastic? Now remember, from this equation 1 at the board, we said that Q is equal to NE. And the Q here is the quantity of charge measured in coulombs. The N is the number of electrons. And the E is the charge of an electron. Remember very well, the charge of an electron, it is minus 1.6 times 10 to the power of, the charge of an electron is a constant, which is 1.6 times 10 to the power of minus 19 coulombs. Now, all they want you to calculate is the number of electrons. Now, remember that Q is equal to NE. So, all I have to do here is to make my N the subject of the formula, and that will give me that N is equal to Q all over E. Remember from the question, you already have the Q, the quantity of the charge, which is minus 0.8 microcoulombs. Whenever you have microcoulombs here, it is times 10 to the power of minus 6. Remember, this is charge. You divide it by the charge of an electron, minus 1.6 times 10 to the power of minus 19 coulombs. This will cancel this. If you punch it in your calculator, what you will get is the number of electrons is 5 times 10 to the power of 12. That is the answer. Now, a small copper plate has a mass of 3 grams. The atomic number of copper is Z, which is equal to 29. And the atomic mass is 63.5 grams per mole. What is the total charge of the electrons in the copper plate? Now, if you watch my videos on stoichiometry, this is an easy question. First of all, what I want to do is I want to change from grams of copper to the number of atoms of copper. That is very simple. Remember, I wrote a simple formula for you that 1 mole of copper is equivalent to 63.5 grams of copper, which is also equivalent to 6.02 times 10 to the power of 23 atoms. Now, I have from the question, I only have grams and atoms. So what I want to do is, I want to convert from grams to atom. So, first of all, what you have to do is, you will carry this relationship that 63.5 grams of copper is equal to 6.02 times 10 to the power of 23 atoms. Now, in the question, you already have the mass to be of 3 grams. So, this is 3 grams of copper will give you S of how many atoms? Now, all you need to do is cross multiply. Now, S atoms is equals to 3 times 6.02 times 10 to the power of 23 divided by 63.5. If you punch this in your calculator, what you should get is around 2.84 times 10 to the power of 22 atoms. Now, if you get this, if you arrive at this answer, remember, they want you to calculate the total charge of the electron in the copper plate. And the formula for calculating the total charge is Q is equal to NC. Now, remember, this is the number of electrons. This is the number of electrons. And remember, they said the atomic number of copper is 29. This question is simple and yet tricky. Remember, whenever we are dealing with an atom has an equal number of electron and proton, meaning that ionization has not taken place. Now, look at what is happening here. For you to know the total number of electrons here, we have the total number of atoms here. So this is, remember, this is E. So this will give you, so first of all, we have 29. How many electrons are here? 29 times the number of these atoms here. So this is Q will give you 29 times 2.84 times 10 to the power of 23 times the charge of an electron is minus 1.6 times 10 to the power of minus 19. If you punch that in your calculator very well, So the answer here is minus 1.3 minus 1.32 times 10 to the power of 5 coulombs. That is the answer for this question. The question number 3 at the board. Compute the ratio of the electric to gravitational force between the two protons. Now, remember very well that the electric field, the electric force, is, we have the K, Q1, Q2, all over R squared. And that of the gravitational force is G, M1, M2, all over R squared. Now, remember that the mass is always constant. And from here, they do not give us the charges, so it means that the charges are the same. So Q1 is equals to Q2 and M1 is equals to M2. Now, this is 1.6 times 10 to the power of minus 19 coulombs. The charge of an electron is 1.67 times 10 to the power of minus 27 kg. Now, from here, from the electric force, since Q1 and Q2 are the same, this formula will change to electric force. This one will now be changed to what? Q squared. Now, since M1 and M2 are together, this will change to GM square all over R square, right? This is R square. Remember, they want us to find the ratio of this to this. So this will then be F, the gravitational force, Fg, all over Fe. So I will divide this by Gm square all over R square. Now listen, this will cancel this, right? So we'll be left with K, Q square all over Gm square. Now that is the formula we are going to be left with. Now all you have to do right now is insert it and press your calculator and the answer will flow naturally. Now inserting this formula, this will give us the K is a constant, right? Which is 9 times 10 to the power of 9 times the charge of an electron, minus 1.6 times 10 to the power of minus 19. Remember, it's all in square. Now, this is gravitational constant, and this is 6.67 times 10 to the power of minus 11, right? Now, the mass of an electron is 1.67 times 10 to the power of minus 27, all in square. You punch this in the calculator, you arrive that the ratio of the gravitational electric force and gravitational force will give you 1.24 times 10 to the power of 36. What is the magnitude of the electrostatic force of attraction between an alpha particle and an electron? Now, if I draw a line here, and then this is my alpha particle, and this is my electron E. Now remember that an alpha particle have this symbol. This is 4 and this is 2. An alpha particle have an atomic number of 2 and the mass number is 4. And remember, atom have the same number of proton and electron. Now, if I call this one Q1, let me call this Q1, and I call this Q2. Remember I said, that means that the charge here, the number of electrons here should be 2. Let me call it 2e. And here, remember, it is between the magnitude of electrostatic force and an alpha particle. So, why this one, the charge here is just an E. That's all. Remember, when we talk about electrostatic force, this is the formula that K1, Q1, Q2 all over R squared. Now, remember that they already separated by a distance, this already in meters. So, insert it. This is 9 times 10 raised to the power of 9, a constant, times my Q1 now is 2E, right? An alpha particle from this formula, that's where I picked it. This is a normal electron, so you just have an E times my Q2 is E divided by R squared. Now this will give me 9 times 9 times 10 raised to the power of 9 times 2E squared all over 1 times 10 raised to the power of minus 13. Remember, everything is in square. Now remember that the charge of an electron is minus 1.6 times 10 raised to the power of minus 19 coulombs. Now all you need to do now, if I insert this here, we have 9 times 10 raised to the power of 9 times 2 into minus 1.6 times 10 raised to the power of 19c all over 1 times 10 raised to the power of minus 13 all in square. So right now all you need to do is 0.6 times 10 raised to the power of minus 2, and the unit is newtons. 2-point charges are separated by a distance d, and they experience a force F. What would the force be? They want you to calculate the force if the two charges move to a distance of d all over 4 apart. Remember from electrostatic force that we say the force is inversely proportional to the square of the distance apart. Now, if I want to remove the proportionality sign, I will introduce a constant, which is F is equal to K all over R squared. Remember, we did this thing when it comes to my channel on electric charges. I've explained these formulas before. So from here, this is all over 1. I want to cross multiply, so this will give me F R squared is equals to K. So it means that F R squared is equals to a constant. So what it means is that I can conveniently say that F1 R1 squared is equals to F2 R2 squared. Now, remember from the equation, they said that the first distance is D. It means that your R1 is equals to D, and your F1 is equal to F. Now, they want you to calculate F2, given that the distance D2, given that D2 is separated by D all over 4. So all I need to do is make F2 subject of the formula, and that will give me F2 is equal to F1 R1 squared all over R2 squared. Now, inserting this into this formula from here, my F2 is now, my F1, remember, is F. My R1, remember, is D, right? Now, all over, let me put times here. My R2 is what? The R2 is D all over 4. Can you see it? Now, don't forget that this is square. My D is square. This is also square from this formula here. So, look at what is going to happen. Your F2 is equal to F D square all over D square all over 16. From here, this of course will go with this. So we are left with F2 will be equals to F all over 1 divided by 16. So from here now, that's what we call the principle of keep. You keep this, you change this, you flip this. So F2 is you keep F, you change division to multiplication, which is times, and then you flip this. And once you flip it, it will be 16 all over 1. So your F2 is 16F. That is the answer. So the first we have there is 16F. Remember I said I use the principle of keep, change, flip. Two charges, Q1 is equal to 25 microcoulombs, Q2 is equal to 50 microcoulombs, are located on the SY plane at the positions. This is R1 and R2. Find the force exerted on Q2 by Q1. This question is simple yet complicated. It means that if you do not remember your first semester physics, or if you do not remember how to solve vectors, you have a problem with this question. What am I talking about? We'll be calculating the electrostatic force, and then we'll be joining it using the what we call the unit vector. Now, let's go. From the question, we have given your Q1 is 25. Whenever you have microcoulombs, you times it by times 10 raised to the power of minus 6 coulombs. Your Q2 is 50 times 10 raised to the power of minus 6 coulombs. Now, located at the Rm. Now, first of all, you have the R1, the vector of R1, 3jm, R2 vector, 4im. Now, what you have to do right now is to get the resultant of these two first. So the resultant here is the square root of 3 square plus 4 square, and that will give you 16 plus 9 plus 16, which will give you 25, which will give you 5. Now you have gotten the resultant of these two vectors. Now remember that electrostatic force is F is equal to Q, K, Q1, Q2 all over R squared. Now, since we have two vectors attached to this question, here will then be something like that. I'll put R and I'll put this symbol. If you know vectors well, immediately I put this symbol. It means that if you put the formula for electrostatic force, you attach it to that of the unit vector, because this is a calculation of electrostatic force involving vector. So this is how you solve it. And remember, whenever we want to calculate unit vector, that unit vector of R is first R2, the vector of 2 minus R1 all over the resultant of R2 to 1, since we are going from the R2 to R1. Now look at what I'm saying. So this is the formula we use. Why this unit vector? Look at the formula here. Now we have already gotten the resultant, which is when we got to the 5. Now all we need to do right now is to minus it and attach this formula. So your F1, your F is equal to 9 times 10 raised to the power of 9. Your Q1 is 25 times 10 raised to the power of minus 6. Your Q2 is 50 times 10 raised to the power of minus 6, right? The distance separating these two forces, of course, we just calculated it to be the resultant, and that would be 5 squared. Now, times the unit vector times this. Now, remember that this has a unit vector of the R2 is 4i minus 3j, right? All over the resultant, we calculated it to be 5. That's all. Now look at what you do. You times this and stop here, divide it by this. Whatever you get, you keep the answer. Now here will be 5. Whatever we get now will be 4 divided by 5 should give you 0.8i minus 0.4j. Whatever we get from this place, we attach it to this. Give you 0.45. Now your F is now 0.36i minus 0.27 J. So remember, everything is in Newton. Everything is in Newton. Everything you need to do is, okay, this is involved with vectors. You know the formula for calculating the electrostatic charges. You put your unit vector. And of course, the distance separating the two is always the resultant. So once you do it and you just add it to unit vector here, you punch your calculator, the answer will flow naturally. That's why this is under electric field. Find the electric field at a point 20 cm from a charge of 20 microcoulombs. Now, this question is 2 in 1. It continues. What force will the field exert on a charge of 5 microcoulombs placed at that point? So the first thing, remember that the electric field, the formula is force per charge. And remember that if force is K, Q1, Q2, all over Q, it means that electric field, this is force per charge. If I divide everything by charge here, this one will cancel 1 here. So electric field have only one charge, KQ all over R squared. So this is equation 1. This is equation 2. Now, recall from the equation, find the electric field at a point. So you have your R to be 20 meters. You divide by 100 to convert it to meters. Now, it has a charge of 20 microcoulombs. So this is just, so your electric field here is 9 times 10 raised to the power of 9 times 20 times 10 raised to the power of 6. Minus 6. You divide all through by your R, which is 0.2 square. Now, if you punch your calculator, this will give you 4.6. 4.5 times 10 raised to the power of 6. So this will give you 4.5 times 10 raised to the power of 6 Newton per coulomb. Now, that is for the first part. The second part is said, what force will it exert on a charge of 5 microcoulombs? So, electric field is force all over charge. So, force will now be electric field times charge. Now, electric field here, we already gotten it to be 4.5 times 10 raised to the power of 6. You now times it by the charge, which is 5 times 10 raised to the power of minus 6. Whatever it gives you should be the answer, which is around 22 point something. So that will give you 22.5 newtons. This will give you 22.5 newton. And that is the answer for that. The electric field strength of a unit charge is given by this. Calculate the following parameters. 1 is this symbol means the resultant of E. And the 2 is the unit vector of the field. Now, for you to get the resultant, it's simple. All you need to do is square root of 3 square plus 4 square plus 5 square. So, if you calculate, what you should get is 7.07. So, having gotten this, the electric here is the unit vector. We said that is the vector of E all over resultant of E. Now, all you need to do is the vector already given, you write it here. Now, you divide it by the resultant, which is 7.07. So, if you divide 3 divided by 7.07, what you will get is 0.42i, plus if you divide 4 by this, what you get is this. If you divide 5 divided by this, what you get is this. And that is the answer. Thank you very much. Please, even if you download my video and you are not giving me a thumbs up or comments, you are not helping the channel to grow, and I may not be motivated to do more. Thank you very much.